And it's recording. All right. Exercise 4G. You got it? Very good. All right, 4G. Today's lesson, 4G is a nice, quick, simple idea. Thank you. Please don't speak while I'm speaking. You're either taking notes or you're sitting there quietly. Here we go. So exercise 4G is called total surface area. The idea is that you are now taking a 3D shape. So all the shapes in 4G is 3D. And your goal is to think about if I had to paint this 3D shape, which is all of the exterior surface space, that's what you're looking for. Now, in order to do that, it means that you need to know all the formulas for 4C, is it D? Yeah, CD, then 4B, 4E, 4F. Okay, now let's do a quick recap because there were 8 shapes in total that you needed to know. Recap, 4C. What kind of shapes do we have in 4C that you had to remember? Name me one. Let's go with Nick.
Square.
Square. Very good. We have a square. Give me another one, Charlie. We have circles not in 4C. Triangles. Very good. So we have triangles. So you need to know the area of a square. Triangle. What else? Jacob. Rectangle. Great. These are all the basic shapes that you would have seen in primary school. That's 4C. There's still one more basic shape that we're missing in 4C. What's another one? What's another one? Charlotte?
Parallelogram.
Very good, parallelogram. So a tilted rectangle, that's 4C. Then we go into 4D, it's just adding on some newer shapes, some little nuances to it. So those are your 4 that you needed to know: square, rectangle, triangle, parallelogram. 4D, there were 3 special shapes. Tilla, name me one. 4D. So we had square, rectangle, triangle, parallelogram. What am I missing? 3 special shapes. Good. We have a rhombus, which kind of looks like a parallelogram. The only difference is all the sides are the same. So think of it as a square tilted. So this one is a rectangle tilted. This one is a square tilted, right? What's the other 2 in 4D? Willem? Very good. So we have a kite, sometimes called a diamond. And one of the key differences to note is that the opposite sides are not equal. See, in all these shapes, opposite lengths are the same. So these 2 are the same. These 2 are the same. These 2 are the same. Kite. It's the only one where the opposites sides do not equal. So you got to look at the symbols. What's the last shape, which is usually the hardest formula to remember? Yes, Eknor? Trapezium. Thanks, Xavier. Please don't speak while I'm speaking. Trapezium. The other ones I'm going to assume that you remember. These ones is the basic ones that you should know by now. Let's check 4D again. The nice thing about rhombus and kite is they have the same formula. What was the formula, Yuchen? Good. And what does P and Q stand for? Good. So diagonal 1 times diagonal 2, and then you halve it. So the diagonals in the shapes. So from corner to corner, if you times these 2 diagonals and then halve it, that's the area for kites and rhombus. Trapezium. What was the formula for trapezium, Belinda?
A plus B times height over square.
Very good. What's A and B stand for again? Let's go with Xavier.
1 and 2. Like shape 1 and shape 2.
Ooh, cool. Not really, but I can see what you were thinking. Someone else. So the formula is half times A plus B times height. So you got a trapezium. You need to know what A and B is. Nick?
The bases?
The bases. It's the 2 parallel lines. So if you look at the shape, these 2, what makes a trapezium a trapezium? It has to have 1 pair of parallel lines. All the other ones have 2. See, this one has 2 pairs. Those 2 are pairs. Those 2 are pairs. These 2 are pairs. This is the only one that has 1 pair. So those 2 pairs of parallel lines, that's what A and B is. So this is your A, that's your B. Okay, so A and B is your 2 parallel lines. Distance between them, that's 90 degrees. That's your height. Okay? And that summarizes your 7 formulas 4C, 4D, just two exercises that you've been doing for now 3 weeks. 4C, 4D, to remember those formulas there. Then Charlie mentioned before circles, 4B, E, and F are circles. So as long as you know two formulas for a circle, there's two things you have to know. One is the area. What's the area of a circle? Again, let's go with, who haven't I chosen? Let's go with Grissa. What's the area of a circle again? Good. Pi times radius squared, which is what students confuse with circumference. What's the circumference formula again? Let's go with Hamza. Ooh, close. 2 times radius. There's pi, but not squared. And that's the one I'm saying most students confuse between. Because area is the ones with the square. Circumference, 2 times r gives you the diameter. Remember, to find the distance around a circle, it's your diameter times by pi. Okay? So what I just quickly summarized for you there, those are your 8 shapes that you need to know. And with those 8 shapes, then you can do 4G. 4G is just identifying the shapes that you break out into your net position to find the areas. So let's do the first one here. Let's fill in some notes. Total surface area is the sum of the areas of all its, starting with F, faces. Write it in, faces. So when you're talking about a 3D shape, the exterior shapes is called the faces. Okay, so write that in. So let's say, for example, this shape here. When you fold them all up together, fold each one, push them all together, you get a cube. So with a cube, how many faces does a cube have? Let's go with Zara. How many faces does a cube have? 6. Very good. We've got the front. That's 1. Got the back. That's 2. Then we've got the left side, right side. That's 4 now. And then we've got the top. And we also got the bottom. That's 6. Okay, so that means each one, if you had to paint this cube, you'd have to find the area that you need to paint of all 6 sides, or 6 faces. That's what you're doing in this session, is you identify how many faces there are and how much space you need to color in total. So in this case here, it has a total of 6 faces. How do you find the area of each face? Well, each face is actually a square. So we know the area of a square is L times L. That's why they wrote L squared. How many faces are there? Well, there's 1 over here, L squared, plus another 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 L squared, which is what this line is saying. So now we have L squared plus L squared plus L squared, so we're just missing 2 more. Or you can write 6 times L squared, and that's the formula for the surface area of a cube. Let's do one example together. Let's see if you can see the number of faces here. Let's have a look at this one. Just below, what type of shape is this? What is this one called? Triangular? Prism. Prism because you can cut them, and when you pull them apart, the faces on each end is always the same. That's when it's a prism. Okay? Let's do it. How many faces does this triangular prism have? Let's go with Ollie. How many faces do you see in this triangular prism? 2. So we can see the front. That's 1. So if you had to paint this shape, think about the 3D. I can paint the front. I can also paint the back. Oh, okay, good. So you can see 5 now. So that's 1, 2, front, back. There's the top diagonal, both sides. So that's now 4. And then finally the bottom that you paint, that's 5 in total. So there are 5 areas that you need to add in total. But each shape is slightly different. The front face. So area of the front. What kind of shape do I have at the front there? Can I please have Nick? What kind of shape is this? Triangle. So when I say area of front, you're really trying to figure out the area of a triangle. Let's revise. What's the area of a triangle again? Let's go with Willem. What's the formula for area of a triangle? Very good. So length times height divided by 2, or some of you might have learned it as base times height divided by 2. Doesn't matter. The point is you need a length and you need a perpendicular or 90 degrees length to it. In this case, we've got 6 as the base, and we've got the height as 4. So if you write it in, the formula should then be 6 times height, which is 4, divided by 2. You can use a calculator or do quick calculations here. What's 6 times 4? Let's go with Josh. 6 times 4. 24. And then you divide that by 2. 12. Very good. So this gives you 12. But remember, you don't just write 12 centimeters. You're going to have the square, but the way we pronounce it, squared centimeters. Very good. So it's 12 squared centimeters is the area for the front of this shape. So that's how much paint, if you were painting it, that's how much paint you need. You need 12 squared centimeters. But if you have the front, you also have the back. So now you don't have to calculate the back because you know the back is exactly the same shape because it's a prism. So that means it's 12 again for the back. 12 squared centimeters. Great. Ollie said there was 5 faces in total. We've calculated 2, so we've got 3 more to go. Let's go with the diagonal lengths on the top here and the sides here. Sorry, on the sides. So imagine painting the sides in blue. What shape is that? Can I please have, let's go with Attila. What shape is this in blue? It's a rectangle. Good. So the sides is a rectangle. Fitzroy, what's the formula for the area of a rectangle again? Good. Length times width. So in this case, our length, clearly I can see it's 10. My width must be 5. Very good, because it's saying from here to here is 5. So that means the shape is length 10 times width is 5. 50 squared centimeters. But because it's tilted on an angle, the other side's exactly the same as well. There's 10 and there's also 5 on the other side. So therefore, and how do I know it's 5 on the other side? Notice there's a dash here. That means this diagonal and this diagonal are the same lengths. So this must be 5 as well. That's why I know the other side is also a rectangle of 10 by 5. So really, I need to times this by 2 because I got 2 of them. That's now 100 squared centimeters. What face am I missing now? So I got 2 sides. I've got front and back. That's 4 faces, but there's 5 faces in total. So which one am I missing? Bottom. What shape is the bottom one? Can I please have Hamza? Rectangle again. Length times width again. And in this case, what is my length and width? Let's go with Aqualia. So if I want the area of the bottom, which is this one, what's my length and width? Ooh, close. 4 is actually this height. So you want the bottom. So you got 10. We need this length. 6. Very good. So that rectangle, if you picture it, that's 10 by 6 on the bottom. So here we go. We'll write then 10. Length is 10 times 6. 60 squared centimeters. And that's all of the areas that we need. But if you were to go by paint, you need to know total. So each time you buy a bucket, it tells you how much it can contain. Well, first thing we need to know, well, how much do I need in total? So I needed 12 for the front, 12 for the back. I needed 50 for one of the sides, the diagonal side lengths, and then another 50 for the diagonal side lengths. And then finally the bottom, we know it's 60. So let's add them all together. How much total paint did I actually need? 50 plus 50 was easy. That's 100. Plus 60, that's 160. 12 and 12 is 24. So what is 160 plus 24? That's 160 there. This is 24. What's 160 plus 24?
184.
184. So I know when they say total surface area, that's what they mean. What's the total, if you were to paint this, no matter which shape you get, what's the total area that you need in order to go paint it? And you would do that when you're painting your home. So if your parents ever done any renovations where they're repainting the walls, they would have done what we just did, but it's a bit easier. So you just kind of calculate the area of this wall here, area of this wall, and then you go into Bunnings and you pick up a bucket and it tells you. It tells you per square meter. So they'll say per square meter and then how many of it has. Sometimes they even just tell you how much of a wall or how many meters it will cover. That's what you use to figure out how many buckets you need. Otherwise, what do most people do without calculations? They just estimate. They might buy 2 buckets and they might be missing, or they buy 3 buckets and they have too much. They just leave paint there. That's the most common thing. So when I moved into this house that I got, I saw 3 buckets. All 3 of them were opened and all of them were partly used. It just means that they didn't really count. They just went and grabbed 3 buckets and I saw it in the little area and it's been there for so long. The cap was taken off, so it's all dried in there, so it's pretty much useless to me too. But that's the point. You either waste money, so imagine if you're owning a business. You don't want to be wasting your money. You want to make sure that you're using every single bit of the paint to make it efficient. That's the point of the calculations. You don't need calculations to live in life. You just wing it. It just means money. You pay for your mistakes, and if you do some calculations, that's where you make profit, or you maximize it. Okay? But that's the idea of understanding total surface area, and each shape will slightly be different. So for example, this one, it's a prism again. How do you know it's a prism? Same thing. If you cut it and you separate it, the faces from the front and back is always going to be the same. This one, you have to split them up. So you have to find out, how do you find the area of the front face? Hopefully you can see here, this is actually a triangle sitting on top of a rectangle. So length by width and then area of a triangle on the top. That's how you get the front face. So that's the problem solving component. I'm going to stop the video there. That's just for you to understand what total surface area is. In the last 10 minutes, I want you to have a go with this problem. I'm going to write up the solutions and then I want you to check your answers if you've done it correctly. So it's more about layout, more about consistency, less so about the answer, because everyone here understands what total surface area is, but how you calculate it, that depends on your layout. Okay, the more logical you are, the less likely you're going to make a mistake. So take your time, use a calculator. I'm going to pause the video here.